Alright, welcome to the exciting world of logarithms. And what we're going to do is we're going to study logs today. But before we do that, I want to take you back to about grade 7 or grade 8. And you had an equation, and it was something very trivial, or at least you think it's very trivial by now. Something like 5x equals to 10. Now, we all know how to solve this. What did we do? We wanted to isolate for x. Now, how do we isolate for x? Well, what we do is we apply the inverse operator. See, x is being multiplied here by 5. So we took what we already had and we applied the inverse, which was division, right? Because the inverse of multiplication would be division. So we divide each side by 5 and we get the correct answer, that x is equal to 2. Why did I start off with this? Well, I want you to start thinking in terms of inverse operators. When a variable is being operated on and you want to isolate it, you want to think, what is the inverse operation? Over here, the inverse operation was the operation was multiplication, thus the inverse was division. Now, let's start studying the world of logarithms. Why study logs? Well, as you would see in class, that everything in nature that has to do with growth grows exponentially. And everything that decays exponentially. It either decays like this or it decays like that. So we need to study logarithms because logs are the inverse operators of exponentials. What do I mean by that? Well, if you have an equation that looks something like this, 2 to the power of x is equal to 8. Now, when we had multiplication here, we divided to isolate for x. How would you isolate for this guy? It's a little bit trickier. And that's how we do it. We use logs. Before I jump into practical examples, what I want to do is give you a little bit of theory that I want you guys to accept. Accept them as axioms, something that we're not going to prove for now, but you know is true and you're going to trust that it's true, and it's going to make our life really, really easy. The first thing is, when you have log of, so b to the power of x, and you have log of base a, and don't worry about the fact that you don't know what this means right now, but if you have something like this, it is equivalent to x log ab. What have I just done? Well, I've taken this x and I've moved it down there, and that's why we get the x here. This is a key feature of logs, because what ends up happening is if we want to isolate something like 2 to the x, well, we need the x to come down here somehow. So this is the first key property that I want you to remember. The second one is that log of base b, and when you take b, is equal to 1. Let's see a practical example of this. Let's say I have 10 to the power of x is equal to 100. Now, we know the answer to this. We can probably guess that, well, 10 times 10 is equal to 100. Therefore, x must be equal to 2. Now, that's fine for this example, but what if it was 10 to the power of x is equal to 10 billion? We don't want to be guessing or doing more work than it's necessary because we're mathematicians. We want to be smart about it. So we use this law, log of base a to the power of log of base a applied to b to the power of x, so we can move this x down there. Now, what I'm going to do is I'm going to apply log of base 10. And the reason I do that is because I know if I have log of base something and I take it over here, the number and the base are the same, it's equal to 1. So I'm going to do log of base 10 and apply it to 10 to the power of x. Okay? Now, by the first property, I'm allowed to move this guy down here. So that's x log 10 to the 10. And because I did this to one side, I have to do it here. So log 10, 100. And this is separate. Okay. Now I know that log base 10 of 10 is equal to 1. So I can forget about that. And I've accomplished what I set out to accomplish, which was to get x on its own. I want x on its own so I can solve this problem. So x is equal to log base 10 of 100. And what this problem is saying, well, x is the number that you need to exponentiate 10 with. So 10 to the power of this guy, x, is equal to 100. You can go ahead and use your calculator. The standard log key is actually for base 10. And what you will get is x is equal to 2, all by using your calculator. Now, I'm going to give you one more rule. And we're going to study this in class a lot more in detail, but this is the rule that I want you to remember. Now, log a of b is equal to log base 10 of b log base 10 of a. Now, why is this rule useful? See, the problem here that we had was 10 to the power of something, which is fantastic because our calculator has an operator with log base 10. But what if we were trying to solve the problem 2 to the power of x is equal to 8? How do we do that? We can't do it the same way. We have to convert everything to base 10. And that's not an issue. I'm going to show you how to do this problem right now. So let's get our golden rule down again. Log a of b is equal to log 10b divided by log base 10a. Now, our problem was 2 to the power of x is equal to 8. Great. Let's solve this guy. Once again, we apply logs. So I'm going to go ahead and apply log of base 2 to 2 to the power of x. Why do I apply base 2? Because I know that log 2, I know that all this cancels out and becomes 1. So that makes my life easy. But because I did log base 2 on one side of the equation, I have to do it on the other side. Okay? So now, because of the rules we discussed on the previous slide, this x is about to come down here. X times log 2 of 2. I know this cancels out to be 1, is equal to log base 2 of 8. We don't have a key for log base 2, but we're going to use this rule right here to solve, because this converts any base into base 10. So x is equal to log base 2 of 8. And now I'm going to take log base 10. The first number, 8, divided by log 10 of 2. And if you punch that in your calculator, you'll get 3. X is equal to 3. And that is the correct answer indeed, because 2 to the power of 3 is equal to 8. Awesome. So we just learned in 9 minutes how to solve logs not only of base 10, but also of any base, because we can use this magic formula that we have to convert from any base to base 10. We also talked about why logs are important. They're inverse operators. Just like to solve an algebraic equation of 5x is equal to 10, we use the inverse operator. If you have an equation of this form, the only way to solve it is by using logs. So that was a quick introduction to logs. And don't worry if you don't understand it or if you're struggling with it. We will discuss it in great detail in the classroom. So I'll see you there.